Hello friends, I welcome you all to this session on C programming. So today we'll be solving some problems using loop, basically using while loop only. So it says that factorial of a number has to be evaluated using while loop. Then Fibonacci series have to be printed up to n terms. And then the third problem says that check whether a number entered by the user is prime or not. So how to do this? So now if you look this, the first problem, factorial of a number. So what is a factorial of a number? So n factorial is basically n multiplied by n minus 1 multiplied by n minus 1 2 dot 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 up to 2 multiplied by 1 and that's it. So the thing is that I can also write this thing in reverse order, that is 1 times 2 times 3 up to n minus 1 times 1. So that is how we will be proceeding. So if I require what is the factorial of 5, I will be writing 1 into 2 into 3 into 4 into 5. Now again you can see that what are these? These are nothing but counters, 1, 2, 3, 4, 5. So I will be starting my counter at 1, ending my counter at 5, basically at n. Okay, so n is the last point. So when that counter becomes exactly equal to n, I will stop. And what I have to do? I have to multiply every term. So let us start with f as 1. So if I multiply that f with I, so what will happen initially? And so let me make a table. So this is f and this is f times I. So initially f is 1, I is also 1, so it is 1 times 1, that is 1, as well as I. Okay, I is 1. Then I becomes 2. Okay, now what is this? This is not required. So what is this? This is basically 1, that is f times I, that is 2. So it becomes 2. Then I becomes 3. So it will be 2 times 3, that is 6, and so on. So that is how we have to start. So let us head to code blocks. So here first I require that n, and then I ask that n from user. So enter the number. Okay, then scanf percentage d, as this is integer, so at the address of n, and then I will be starting with one counter, let's say I, and initializing it with 1, as well as that f where I will be storing everything, so I will be initializing it with 1 also. Now while the counter I is less than or equal to n, what I have to do? I have to simply multiply that f to I and assign it to f. That's it, done. So at last we just have to print the value of f. So I'll be writing like this: percentage d factorial is equal to percentage d. That is, in the first place here what will be coming, that is n will be coming, and in the second place I require factorial, so f will be coming. So if I run this program, let's say enter a number, I am interested in the factorial of, let's say, 2. So what is the factorial of 2? So 2 factorial is 2 into 1. So this again I am showing you that I have done a mistake, because the more you learn by mistake, it is better, because at every time you should be doing some mistake, you will be learning by your mistake, so that that mistake cannot be repeated in future. And the mistake I used to do commonly is the mistake which normally people do, that means making a loop infinite. So how to handle it? Yes, you are right. What we have done is we have initialized I with 1, and we have never ever incremented I. So I assigned I plus 1. Remember, don't forget this. Okay, so let's say I'm interested in factorial 2. So 2 factorial is nothing but 2. Okay, so let us try to find out what is 4 factorial. So 4 factorial is 24. What is 5 factorial? So 5 factorial is 120 and so on. So what we have done is we have taken this variable f, assigned it with 1, and then inside the loop I have multiplied that f by I and assigned it to f itself. So that continuously it will be multiplying by itself, and the program or the loop will stop when the value of I is trying to exceed that n, or the last iteration will be the one where I becomes equal to n. So in this way you can write this program. So now comes the second Fibonacci series of a number. So for Fibonacci series, remember that it's normally we write with 1, but it is better to write with start with 0. Then you add these two, what you will be getting 1. So then you add these two, what you will be getting 2. Then you add these two, what you will be getting 3. If you add these two, then this is 5. If you add these two, then this will be 8. If you add these two, then this will be 13, and so on. So in this way, this series looks like. That is how we write it, and that is the logic behind Fibonacci series and the terms. So if I am interested in printing the first n terms, let us say first 5 terms. So what are those? 1, so 1, 2, 3, 4, 5. Okay, and in every term what you are doing is these two are fixed for you. These two are fixed, and then what you will be doing is if you want to get this, you have to add these two. If you want to get this, then you have to add these two. If you want to get this, then you have to add these two. For this term, you have to add. So basically, for every new term I am creating for this series, I am adding the first two or previous two terms. So let us start with the first one, that is f naught, and this is f1, and this is f new term. So I am starting with what? 0 and 1. So fn will be nothing but the sum of f naught and f1. So this will become 1. Then in the next iteration, what will happen? This f1, so as I am moving from this number to this number, so for this number, 0 and 1 are my f0 and f1. But the moment I shift to this, so f1 for the previous term, this one will become f0, and this fn becomes f1. So this will become f0 and this will become f1. So what is this f new? So it is 2. Then in the next iteration, what will happen? This f1 will become f0 and this fn will become f1. So this is 3. So likewise, this will proceed. Okay. So what is the logic? So we have to start with 0 and 1. Okay. So these are two terms. So two terms are already fixed. So if now look very closely. So two terms are there. So if in my series 5 terms, let's say I am interested in printing the first 5 terms. So 2 terms already I have printed. How many terms do I have to evaluate? Next 3 terms. So if I am saying 5, so my loop should run up to this. Let us see this in program. So here n is that particular number, that the number of terms in that series. So this will not change. Let us keep it as such. So I is nothing but the counter. Okay. Now what I require first is f0 and the second one is f1 and assign it with 1. So this is assigned 0 and this is assigned 1. Now while I is less than or equal to n minus 2. Now you have guessed it right. Why? Because two terms we have already fixed. We have started with these two terms. So next 3 terms are required. Then what I have to do inside? The first thing is I have to find out what is fn. What is that? It is nothing but f0 plus f1. Okay. Once this is done, then I have to do what? Then I have to print this term. Okay. So what I have to do? I have to print this. What? Print this, that is print the term. What is that? That is nothing but fn. Okay, then what? Then I have to increment it. That's it. Done. And as these are also your terms, so um, what you do, you also print them. That is percentage d comma percentage d, and first one is f0 and then f1. Okay, so now if you run this program, let us see what happens. So there is a mistake. It is saying that fn is not known. Yes, it is correct. Fn is not known. Why it is not known? Because we have not declared it. So let us also declare this fn here. So if now we run it, the number of terms, let's say 5 terms. So it is saying 0, then 1, then why it is doing this? Can you tell me why? There is a mistake. What is the mistake? First one is that we have to write here comma. Okay, that is not a very big deal. But why it is coming 1, 1, 1? Now you guessed it right, because here we have to transfer f1 to f0 and fn to f1 once it get printed, once the term get printed. Because what is your series here? This is your series, this one. Okay, so these you are printing in priori and then you are printing them. But once this is printed, then you have to shift it. So this is the problem. So once this is printed, so f naught will be taking the value of f1, and f1 will be taking the value of fn. Now if you run this, so let me write comma also here. Now if you run this, let us say first 5 terms. So now you are getting it 0, 1, 1, 2, 3. How many terms are there? 1, 2, 3, 4, 5. 5 terms are there. Let's say I am interested in printing the first 10 terms. So these are the first 10 terms: 0, 1, 1, 2, 3, 5, 8, 13, 21, 24, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So in this way you can print your Fibonacci series. Okay, now comes the last problem to check if a number is prime or not. When a number is prime, let's say I am interested in checking whether 3 is prime number or not, whether 6 is prime number or not, whether 9 is prime number or not, or whether 7 is prime number or not. So how many numbers divide this 3? There are only 2, either 1 or this 3. That means 1 and the number itself. Also, how many numbers divide this 6? They are 1, okay, then 2, then 3, then 6. Oh, okay. How many number divide this 9? It is 1. Number 3 divide this, and 9 also divide this number. How many number divide this 7? 1 and 7 itself. So if a number is divisible only and only by 2 numbers, that is 1 and 7, then that particular number is prime. Remember. So if the count of this, that is the division, that is the number which divide this, is coming exactly equal to 2, then that is a prime number. Now check whether 1 is a prime or not. 1 is divisible by 1. That's it. What is the count? 1. So 1 is not a prime number. So all the numbers which are either divided by 1 or themselves, that means the count of number dividing that number is 2 only, then that is a prime number. So that is my logic. So what is my logic? The logic says I must have one number. Okay, I am having one. Then what? I will start dividing that number from 1. So 1 always divide any number. So I will be having this count and I will be incrementing it by 1, because 1 divides it. Then I will move to next number 2, then 3, up to that particular number I will move. And if any number divides, then I will be adding it. Okay. Then at last I will be checking if this count is less than, if this count is exactly equal to 2 or not. If that is exactly equal to 2, then that is prime, otherwise not. So let us write a program for it. So what is required? That number is required, so this will remain as such. Okay, this I will be required, so this will remain. This will be remained as such. So let us make one count also and initialize it with 0, because that is only incremented once I get a number which divide that n. Okay, so while I is less than equal to n, yes, then what? Then I have to write like this. Look, if the number is divided by I, if the number is divided by I, that means the remainder is 0, then do what? Then increment that count by 1. Increment that count by 1. Else don't do anything. Okay. If this is becoming false, then simply increase the I and check for the next I, and so on till the number I, that is the main counter, becomes equal to that number itself. And at last, what I have to do, I have to check if this count becomes exactly equal to 2. If this count is exactly equal to 2, then what I have to say? Simply print that this number is prime. Okay. Else what you have to say? Else the number is not prime. So let me copy this. Else this is not prime. Done. Simple. So let us run this program. Enter a number. Let me check that whether 1 is prime or not. No. Why it is saying 0 is not prime? Why it is saying 0 is not prime? Can you tell me why? What mistake I have done? Yes, you are right. This is percentage D, and what is coming there? So it should be N. Yes, you have correct. You guys did correct. So let us say 1. So 1 is not prime. Let us take another number. Let's say 5. 5 is a prime number. Let's take another number. Let's say 3. 3 is a prime number. Let's take another number. Let's say 10. 10 is not prime number. Let's take another number, 15. So 15 is divisible by 1, 15 is divisible by 3, 15 is divisible by 5, 15 is divisible by 15. So a count is more than 2. So it is not a prime. So in this way, friends, you can create or write a program to check whether a number entered by the user is prime or not. So this is very simple logic, and this can be done in other ways also. You try it yourself. So in this lecture, what I have done, I have covered 3 problems, and in the next lecture I will be starting with some numbers, and we'll be finding out the sum of number, counting the number of digits in a number, and then we'll be multiplying the numbers, and we'll be doing so much work. Okay, so in this lecture till this point only. Thank you very much for watching it.